Before we get on to the long-waiting topic of dynamic arrays, I would like to talk about just a few more small topics. And the first one is how we can implement a queue using two stacks. So that'll be some exercise for you to do. So that's you can think about, we have some class called a stack queue. So basically we have a class over here called stack queue, which implements our interface called queue for the standard queue ADT. And remember, we actually got three similar implementing classes for the same interface earlier, which is the array queue, and also the link queue, and also a circular array queue, which is your exercise assigned earlier. So all these four classes, including the stack queue, they are implementing the same interface queue, meaning that inside each of the classes, you have to internally declare some attributes to really support the public operations or methods for the queue, including enqueue and deque. So that is, for this particular stack queue over here, given that we have two private attributes, both being stacks. So one is called a in stack and the other one is called out stack. You can definitely look at my solution sketch later to see how exactly they're supposed to function internally. But each one of them will just be a stack of generic items over here. So from the public procession point of view for the queue ADT, we are trying to support the enqueue and deque operations, for example, but internally for this particular class, when the dynamic binding is actually in the play at the runtime, internally it is actually going to boil down into the operations in terms of the two stacks, the in stack and also out stack, right? That's really the polymorphic architecture that we spoke about earlier. And for this class here, it's no exception. It's simply just another example of using polymorphism and dynamic binding. So I'm going to leave that and as an exercise for you. Let's go a little bit further. It's not difficult, but you really need to think about exactly how this will work. And you can definitely use my sketch of the solution over here and then try to maybe implement it and also to test it using JUnit tests. I think that will be also some very beneficial exercise for you, especially to really see what the connection is between the two ADTs. They're quite common, stack and queue. Right, so also think about the running time as well. But I think that in order to figure out the running time, later on when we talk about the asymptotic analysis or especially average analysis of the running time for dynamic arrays, I think that one will give you some inspiration about how to analyze the runtime over here. All right, so that'll be your exercise. And the second thing is about the limitation for the queue ADT. Let's talk about it. Pretty straightforward. So let's say we use a queue to implement a waiting list. Let's say the waiting list maybe for the enrollments for a course for every beginning of every semester, or maybe it's a waiting list maybe for purchasing maybe the latest model for iPhone, right? So we got limited stock, so only certain number of customers can really join the waiting list, something like that. So what if we deque the front customer, right? So the customer has been dequeued. Somehow we found that we want to put them back to the front. Maybe we thought there is some available slot for the customer to be served. So that's why we deque them. However, we found that it's not so ready. So we want to put them back into the queue. Currently, we don't really have this particular operation to really put an item back to the front of the queue. Every time you put some item into the queue, the only operation we have available, according to our interface, is to enqueue to the end of the queue, right? So this will be some very useful function for us to have to really let the customer join directly to the beginning of the queue. And also, what if the customer, let's say at the end of the queue, somehow they decide not to wait any longer and leave? In that case, we don't really have a mechanism to really say deque from the back of the queue, right? So now we are really talking about two scenarios. The standard queue only support insertion to the end and also removal from the beginning. But we may also want to support maybe removal from the end and also insertion to the beginning. So these are the two operations that we would like to maybe support to complement the functionalities of the standard queue. That's really the motivation I'm trying to talk about. Right. So these two example scenarios are just some examples, but I'm pretty sure there are many other scenarios you can think of why the standard queue may not be sufficient for our purpose. Well, what will be the solution? So we may just want to define a new ADT that's also standard. It's more like extending the queue ADT. It's going to extend the queue by supporting two operations. Number one, we want to be able to insert to the front, right? And also we want to be delete from the end. So these two operations are lacking in the standard queue ADT. And as I try to motivate you, so these are just two examples over here. You can think about others as well for your application. Right, so what we're going to introduce now is called the double-ended queue, right? Literally speaking, you can just see we want to support a queue. Somehow, the front of the queue can either be in the beginning or at the end. And also, the end of the queue can also be at the end or in the beginning. Basically, we got two ends of the queue that can be inserted and removed whenever we need it, rather than fixing one side as the beginning and the other side as the end, right? Right, let's now go over this data structure over here. I don't really need to do any visual illustration, which is not very common for me. But anyway, I think this is rather straightforward. I can just go over some slides with the bullet points so we can save more time for our discussion for the dynamic array, which I'm quite looking forward to. So double-ended queue, the acronym is also called Deque. It's not called deque. Deque is the operation for the queue. It's called Deque. Okay, it's a queue-like data structure which will support the insertion and deletion from both ends. So that's why it's called double-ended queue, right? And let's talk about the interface very quickly. You can think about its interface simply extends the standard queue ADT, but let's just redeclare all the method headers. So we got the size, we got it's empty, we got first, we got add last. You can think about add last over here is what we used to call the in queue for the standard queue. And also remove first is what we used to call deque for the standard queue. But now we cannot say in queue and deque anymore because insertion is now possible for both beginning and the end. And also removal is also possible for the beginning and also the end. So what we have is we also got some extended operation, which you can think about rather than, well, in addition to add last, we can also remove last. In addition to remove first, we can also have add first. So these are exactly the two operations we have, right? So there's very simple ADT. That's a very natural extension to the queue ADT. So whether you should really use a queue ADT as a standard that's actually lacking certain operations, or you actually want to use a double-ended queue, is completely up to your need. But you should just know about what's really the reason or the rationale for designing such an extended ADT over here, right? So exercise for you. You may just want to implement the Deque, double-ended queue data structure or ADT using a circular array. So that's something I will leave to your exercise. Okay, you can think about it. We covered circular array quite thoroughly already, and it was already an exercise for you to really implement your standard queue using the circular array. What about the double-ended queue? Is it possible to really use a circular array? You're gonna follow the same principle. Maybe you have to adapt your methods a little bit to really do this double-ended operation for insertion and deletion. I'll leave that exercise to you. If you want to have discussion with me, I'll be happy to engage. And also, another exercise will be to implement a Deque using maybe some linked lists. You can choose either singly linked list or doubly linked list. Does it really matter in certain scenarios that you can improve the performance using doubly linked list as opposed to singly linked list? That's something I'll leave to your judgment. Right? So these are very good, like a review questions for you to really go beyond the lecture and think about it yourself. And of course, always reach out to me if you want to have some in-depth discussion. Alrighty. So that's about everything I would like to say in this current short video, just to talk about some exercises you can definitely try to do on your own, and also this new extended ADT. We don't really need to go too deep into it because it's rather straightforward, but I would say I'll leave the exercises to you. Alrighty, so if you're ready, let's now move on to the next part, which will be about dynamic arrays.